We learned about chemical equation in the previous session. Today we are going to learn about balanced chemical equation. First of all, we have the definition of balanced chemical equation. A chemical equation which has an equal number of atoms of each element in the reactants and products is called balanced chemical equation. So that means the chemical equation in which equal number of atoms of reactants and products, it is called balanced chemical equation. So in the previous session we learned about chemical equation, how to write chemical equation. So the chemical equation is a representation of a chemical reaction, and we have seen that in chemical equation on the left side of the arrow mark, on the left side of the equation we write chemical formula of the reactants, and on the right side of the equation we will write the chemical formula of the products. So this representation of chemical reaction is called chemical equation. Now, what is balanced chemical equation? So that means if we count the number of atoms of reactants and products, and suppose if we get equal number of reactants and products, that equation is called balanced chemical equation. So I repeat, the equation which has an equal number of atoms of each element in the reactant and product. If there is an equal number of atoms of each element in the reactants and products is called balanced chemical equation. So we have to count the number of atoms of each element in the reactant as well as product side, and if you get equal number of atoms of all the elements on both sides, on both reactant and product side, then we can say that equal number of atoms on reactant and product side. So then that equation is called balanced chemical equation. So you know, before we go for further discussion about balanced chemical equation, we have to know how to count the number of atoms. So it is necessary to learn how to count the number of atoms of the compound. Then only we will be able to find out the given chemical equation is balanced or not. Because if we want to confirm that the given equation is balanced or not, we have to count the number of atoms. So first of all, we will learn how to count the number of atoms. For that, we can consider some examples. So I have written three chemical formula: NH3, P4O10 and NHCO3. So these are the chemical formula of three compounds. So then from chemical formula we can get the number of atoms. So how can we get the number of atoms from the chemical formula? We can see that in every chemical formula there are some numbers like 4, 10, 3, etc. These numbers which appear in chemical formula, these numbers are all subscripts. The number that appears in the chemical formula, it is subscript. So what is the significance of subscript? It indicates the number of atoms. The subscript gives the number of atoms. That means from chemical formula we can get the number of atoms by considering the number. This number is subscript. For example, in this compound P4O10, with P, that subscript is 4. That means 4 P atoms. So what is P? Capital letter P is the symbol of which element? Phosphorus. That means in P4O10, how many phosphorus atoms? 4 phosphorus atoms. Similarly, next one, in P4O10, next atom is oxygen. Capital letter O means oxygen. O10. So subscript is 10. That means there are 10 oxygen atoms. So this is the significance of subscript. So like this we can count the number of atoms of any compound. So from using the subscript we can get the number of atoms. So in P4O10, in this compound, 4 phosphorus atoms, P phosphorus, so 4 phosphorus atoms and 10 oxygen atoms. Next one, NH3, ammonia. In this compound with N, no subscript. That is, if there is no subscript means the number is 1. So NH3 means actually it is N1H3. Is it clear? So if there is no subscript with any atom, that means the subscript will be 1. So we can say that the number of atoms 1. So NH3 means, so we know N1H3. So in NH3, 1 nitrogen atom, N means nitrogen, 1 nitrogen atom and 3 hydrogen atom, because H, capital letter H means which element? Hydrogen. So in NH3, 1 nitrogen atom and 3 hydrogen atoms. So like this we can count the number of atoms. Next, third one we can consider sodium bicarbonate, NaHCO3. In this case, the first atom is Na, second one H, the hydrogen, third one C, capital C, that is carbon, and the fourth one oxygen. So there are 4 atoms in NaHCO3. NaHCO3, how many sodium atoms, how many Na atoms? 1 Na atom, because Na no subscript. If there is no number, no subscript means Na1. So number of sodium atom 1. Second one hydrogen, how many hydrogen atom? Hydrogen, in the case of hydrogen also there is no subscript, that is 1. So H1, 1 hydrogen atom. Then C, with C also no number, so that is 1 carbon atom. C means 1. So C means carbon, and with C no subscript, so 1 carbon atom. 1 carbon atom. And the last one oxygen, O. With oxygen we have 3. The subscript of oxygen is 3. It means there are 3 oxygen atoms. So like this we can count the number of atoms of any compound. So that is these numbers which appear, these numbers are called subscripts. Now we will consider more examples for counting the atoms. The first compound we are going to discuss is H2O, water. In water, H2O. So can we count the number of atoms? Which are the 2 atoms present in water? First one H, second one O. That is, there are 2 atoms only, hydrogen and oxygen. In H2O, how many hydrogen atoms? 2 hydrogen atoms, because of hydrogen subscript 2. So there are 2 hydrogen atoms and O. That is H2O1. No number. With oxygen, no subscript, no number. Therefore, 1. So 1 oxygen atom. Now, the second case, we will consider the same compound H2O only, but it is not H2O now, 2H2O. So we have seen that in H2O, there are 2 hydrogen atoms and 1 oxygen atom. Now we are going to count how many atoms are present in 2H2O. 2H2O means 2 molecules of water. In the first case, it is on H2O only, that is, here it is 1 molecule of H2O. Here 1 molecule of H2O, that is 1 water molecule. In this case, 2H2O, there are 2 water molecules. If there are 2 water molecules, how to write 2H2O? Now, this number 2 is called coefficient. This 2 is not subscript. So, the subscript which we are writing, which gives the number of atoms. But this coefficient which we write before the chemical formula of compound. So, before the chemical formula of compound, we write some numbers. These numbers are called coefficient. So like in mathematical equation, in chemical equation also we can say coefficient like this. For example, in mathematical equation we can suppose we have 4x square y plus 3y square. So in this case the coefficient of this 4x square y is 4, and the second one 3y square, the coefficient of 3y square is 3. Similarly, the numerical coefficient can also appear in chemical equation. So in this case 2 is the coefficient. And what is the significance of coefficient? What is the importance of coefficient? Coefficient gives the number of molecules. So subscript gives number of atoms present in the compound. Then coefficient where we will write the coefficient before the chemical formula of a compound. Before the chemical formula of a compound, we can write coefficient. Coefficient can be 2, 3, 4 and even fractions. Now in this case the coefficient is 2. So when you count the number of atoms of elements into H2O, we have to consider the 2 also. So if there is 2 coefficient, this 2 is common for all the atoms present in the given compound. For that we have to multiply the number of atoms of each element by 2, because 2 is the coefficient and 2 is common for all the atoms present in this compound. So for getting the number of atoms we have to multiply by 2. That is, first we will count the number of hydrogen atom. So number of hydrogen atom will be 2 into 2, 4. 2 2s are 4 hydrogen atom. In H2O we have only 2 hydrogen atom because there is no coefficient, or in other words we can say that the coefficient is 1, but here the coefficient is 2, therefore 2 into 2, 4 hydrogen atom. 2 2s are 4 hydrogen atom. And number of oxygen atom, 2 into 1, H2O1. So number of oxygen atom here 1, so 2 into 1, 2, 2 ones are 2, that is there are 2 oxygen atom. So in 2H2O the number of hydrogen atom 4 hydrogen atoms and the number of oxygen atoms 2 oxygen atom. That means if there is coefficient in chemical equation, when you count the number of atoms of any reactant or product, if there is coefficient like 2, 3, 4 or any coefficient, you have to multiply the number of atoms of each element by the coefficient. So this coefficient will be common for all the atoms. We can consider another one, that is 3H2O. In 3H2O the same compound H2O water, but what is the difference? Coefficient is 3. That means there are 3 molecules of water. If there are 3 molecules of water, we will write it 3H2O. Now can we count the number of each atom? 3. Since 3 is the coefficient, we have to multiply each atom by 3. So hydrogen atom 3 into 2, 6. There are 6 hydrogen atoms. Because 3 is the coefficient, so 3 2s are 6 hydrogen atoms. Now number of oxygen atom 3 ones, 3 into 1, 3 oxygen atoms. So 3 2s are 6 hydrogen atoms, 3 ones are 3 oxygen atoms. So like this we can count number of atoms, and the important point is that the difference between subscript and coefficient. Which is subscript? These numbers 2 or 1, these numbers which appear with the symbol of the element, they are called subscript. Subscript gives the number of atoms, but coefficient gives the number of molecules. So this is the difference between subscript and coefficient. Coefficient gives the number of molecules and subscript gives the number of atoms. Now we can move to the next example. In next case we have another compound, sulfuric acid. Its formula is H2SO4. Sulfuric acid formula is H2SO4. Now we are going to count the number of atoms. First of all, we will count the number of atoms in H2SO4. Is it clear? In H2SO4 how many atoms are there? Check the symbols of each element. Hydrogen is there because H. S means sulfur. O, oxygen. So there are 3 atoms. Which are the 3 atoms? Hydrogen, sulfur and oxygen. Now we will count the atoms of these 3 elements, hydrogen, sulfur and oxygen. First we will count the number of hydrogen atom. In this case in H2SO4 no coefficient, that is 1. Number of hydrogen atom 2 because 2 subscripts, so 2 hydrogen atoms. Sulfur, with sulfur no number, that is 1 sulfur atom, that is S1. With oxygen 4, subscript is 4, therefore there are 4 oxygen atoms. So in H2SO4 molecule, that is in one H2SO4 molecule, in one sulfuric acid molecule, 2 hydrogen atoms, 1 sulfur atom and 4 oxygen atoms. Now we will move to the next, that is same compound but coefficient is different. That is, if there is 2 H2SO4 in the equation, how will you count? 2 is the coefficient, therefore it will be common for all the atoms. So when you count the number of these atoms, we have to multiply by 2. Why? Because now the coefficient is 2. Now can we count? So first hydrogen, first atom hydrogen, number of hydrogen 2, but coefficient is 2, so multiply by 2. 2 into 2, 4 hydrogen atom. Now sulfur 1, so 2 into 1, 2 into 1, 2 sulfur atom. 2 2s are 4 hydrogen atoms, 2 1s are 2 sulfur atoms. Now third one, oxygen. 2 4s are 8 oxygen atom. So in 2 H2SO4 molecule there are 2 2s are 4 hydrogen atoms, 2 1s are 2 sulfur atoms, then 2 4s are 8 oxygen atoms. Now suppose the coefficient is 6. Suppose if the coefficient of H2SO4 is 6 in a chemical equation, how to count? The same procedure. The coefficient is 6, so it will be common for all the atoms. We have to multiply by 6. So like this, 6 into 2, 12 hydrogen atoms, 6 into 1, 6 sulfur atoms, 6 into 4, 24 oxygen atoms. Because 6 is the coefficient. 6 2s are 12 hydrogen atoms, 6 1s are 6 sulfur atoms, 6 4s are 24 oxygen atoms. Now we will discuss the next case, that is the compound is Al2SO4 thrice. Al2SO4 thrice, that is name is aluminum sulfate. Now we are going to count the number of atoms in aluminum sulfate, that is Al2SO4 thrice. So first of all we will find out which are the atoms present in this case. Al2SO4 thrice, the first one is Al, that is aluminum atom. Second S, capital letter S, that is sulfur. Third one oxygen, oxygen atom. So these are the 3 atoms present in this compound: aluminum Al, sulfur S, oxygen O. Now we will count the number of atoms. So the same procedure only, and in this case we can see that the difference is that there are brackets and outside the bracket there is a number of 3. So this is the difference from the previous examples. So we will count Al2, subscript 2, that is number of Al atoms, number of aluminum atoms, 2 Al atoms. Now bracket start, inside the bracket first atom is sulfur S, and number of sulfur atom in bracket we know that there is no number, that means it is 1 only, S1. But the number of sulfur atom is not 1 in this case, because I'll tell you, sulfur is in the brackets. Number of sulfur atoms in this case is 3, because sulfur atom is inside the brackets, and we can see that outside the brackets there is a subscript of 3. So whenever an outside number is there, then this outside number, that is the number which appears outside the bracket, it will be common for all the elements present inside the brackets. So in this case we can see that inside the bracket there are sulfur and oxygen atom. So when you count the number of atoms of sulfur and oxygen atom, we have to consider the number which is present outside also. So in this case, number of sulfur atom already it is 1 into 3, 3. So 1 3s are 3. So 3 sulfur atoms. Now similar is the case of oxygen, because oxygen is also in the brackets. So the number of oxygen atom is 4, but since oxygen is present in the brackets, we have to multiply this 4 by 3, right? Because oxygen is in the brackets. So number of oxygen atom 4 into 3, 4 3s are 12 oxygen atom. So the important point we have to remember is that if there are polyatomic ions in a compound, that is they will come in the brackets. In that case we have to multiply the number of each atom by the outside number. We will consider another one, same compound, aluminum sulfate, Al2SO4 thrice, but in this case we will take in a coefficient of 2, that is if there are two Al2SO4 thrice. Now in this case we know that if there is coefficient in a compound, this coefficient will be common for all the atoms present in the compound. That is, we have to multiply by coefficient also, like previous case only. So number of aluminum atoms will be 2 into 2, 4, because 2 is the coefficient. So 2 2s are 4. And number of sulfur atom will be 2 into 1, 2, then 2 into 3, 6. Understand, sulfur is present in the brackets, so we have to multiply the number of sulfur atom by outside number and also by the coefficient, because coefficient is 2 here. So number of sulfur atom will be 2 into 1 because S1. So 2 into 1 2, 2 into 1 2, then 2 into 3 6. So number of sulfur atoms 6. Then oxygen atom 2 into 4 8, 8 into 3 24. So number of oxygen atom 2 4s are 8, 8 3s are 24. We have to multiply by 3 also because S and O both are in the brackets. So a number of aluminum atoms 2 into 2 4, 4 aluminum atoms, 2 into 1 2, 2 into 3 6 sulfur atoms, 2 4s are 8, 8 3s are 24 oxygen atoms. Now the next one, 3Al2SO4 thrice. The coefficient is 3. So we will multiply number of each atom by the coefficient 3. So the number of aluminum atom will be 3 into 2 6, 6 aluminum atoms, 6 Al atoms. Number of sulfur atom 3 into 1 3, then 3 into 3 9. So in a 3Al2SO4 thrice we have number of sulfur atom will be 3 into 1 S1, 3 into 1 3, then outside the bracket we have again 3, so 3 into 3 9, 3 into 1 3, then 3 into 3 9 sulfur atoms. Then what about oxygen atom? 3 into 4 12, 12 into 3 36, 3 into 4 12 oxygen atom, then 12 into 3 36 oxygen atoms. So in this way we can count the number of atoms of any compound. Next, the last one we are going to discuss, this is number of atoms in ammonium carbonate, NH4 twice CO3, that is the compound we have ammonium carbonate. First we will find out which are the atoms present in this compound. N, that is nitrogen, we have N, H4 that is hydrogen, C carbon, O oxygen. So these are the 4 elements present here, NHCO, nitrogen, hydrogen, carbon and oxygen. First we will count the number of atoms in NH4 twice CO3, then 3 NH4 twice CO3, then 5 NH4 twice CO3 and so on. First of all, in NH4 twice CO3, number of nitrogen atom 2. See, in N and H both are in the brackets. We can see that both N and H, they are in the brackets. So if the atoms are appearing in the brackets, we have to multiply the number of atom by the outside number. Outside the bracket there is 2. Therefore number of nitrogen will be 1 into 2, 2 nitrogen atom. Hydrogen is also in the brackets. So number of hydrogen atom will be 4 into 2, 8 hydrogen atoms. Now next element carbon. Carbon is not in the brackets, and C, no number, no subscript, therefore 1. So C1, 1 carbon atom. Next O, 3, subscript of O is 3, that is 3 oxygen atom. So we have 1 into 2, 2 nitrogen atom, 4 2s are 8 hydrogen atom, 1 carbon atom and 3 oxygen atom. Now we will consider 3 NH4 twice CO3. That is the same compound but the coefficient is 3. Then the number will be like this. 3 is the coefficient, so we have to multiply number of each atom by 3. 3 into 1, number of nitrogen atom here 1, so 3 into 1 3, 3 into 2 6, so 6 nitrogen atom. 3 1s are 3, 3 2s are 6, 6 nitrogen atoms. Now hydrogen, 3 4s are 12, 12 2s are 24. Understand, both N and H both are in the bracket. So 3 1s are 3, 3 2s are 6, 6 N atoms, 3 4s are 12, 12 into 2 24 hydrogen atoms. Now next carbon, 3 into 1, 3 1s are 3 carbon atoms. Oxygen, last one oxygen, 3 3s are 9, 9 oxygen atoms. Now the next one, 5 NH4 twice CO3, the coefficient is 5. So we have to multiply by 5. 5 N1, 5 into 1 5, 5 into 2 10, 5 1s are 5, 5 2s are 10 N atoms. Now hydrogen, 5 4s are 20, 20 into 2, 40. 40 hydrogen atoms. Now carbon, 5 into 1, C1, that is 5 into 1, 5 carbon atoms. Oxygen, 5 into 3, 15. 5 into 3, 15 oxygen atoms. Next is 2 NH4 twice CO3. The coefficient is 2. So multiply by 2. That is 2 into 1. 2 into 1, 2. Then 2 into 2, 4. 2 ones are 2, 2 twos are 4. 4 nitrogen atoms. Now hydrogen, 2 4s are 8, 8 2s are 16. 16 hydrogen atoms. Now carbon, 2 ones are 2, 2 carbon atoms. 2 C atoms, 2 3s are 6. So 2 3s are 6, 6 oxygen atoms. So in this way we can count the number of atoms of any element in the given compound.